Hi, I'm Laramie, and my partner is Lauren, and today we are presenting Antoine Lavoisier's combustion theory.
At the time Antoine Lavoisier was conducting his research, chemistry was a fairly new concept. There was very little experimental research to support it as a science. George Stahl was one of the first scientists to really dive into the field of chemistry. He created the theory of phlogiston. He believed phlogiston was an extremely flammable element involved in combustion. In his theory, he stated that phlogiston would turn into air when it was burned. He used that idea to explain the weight loss experienced by substances when they burn. Lavoisier was already very interested in reactions involving heat and a change of state, so when he heard Stahl's theory, he wanted to put it to the test. He performed several experiments with different elements to determine if Stahl's theory was accurate or not.
Since Lavoisier didn't believe in the phlogiston theory, he decided to disprove it by conducting several experiments. And so the first experiment that he did took place in either September or October of 1772. And he burned white phosphorus and sulfur. And so the way that he did that was he used an apparatus of a bell jar on a mercury reservoir. And so he took the volume of the bell jar that just had regular air in it, and then when he added the substance, he measured the volume again. And the combustion started either by using a heated iron stick or by using a magnifying glass. And so after the combustion had took place, white phosphorus actually produced this white flaky substance. And so this substance had never been seen before. And the best way to figure out what it is to test its properties. And so that's exactly what Lavoisier did. And that's when he discovered that the product was actually soluble in water, which he thought was strange since phosphorus itself is not soluble in water. And so he decided to take the volume of the apparatus system again, and that's when he found out that there was a change. The second experiment that took place in disproving the phlogiston theory was actually presented to Lavoisier by another scientist named Joseph Priestley. Priestley and Lavoisier met in Paris, and Priestley had told Lavoisier of his experiments in heating metal calces. And the results did not necessarily make sense to Lavoisier. So he decided to repeat these experiments for his own to see if Priestley had taken his measurements right. So these experiments took place in August of 1774. The apparatus used to conduct the experiment was a bell jar on a mercury reservoir, a flask that contained mercury that was on top of a heating chamber, and this was attached to the bell jar. And so the mercury flask was then heated, and this heating process took place for several days, and the mercury in the bell jar rose. And when the mercury in the bell jar stopped rising, that's when they knew to take the mercury flask off the heating chamber. And so they found this red mercury calx that was produced on top of the flask. And so they decided to then test its properties to see how exactly this was produced and what the components were that made up with it. The results of the second experiment really made Lavoisier feel like he only needed a little bit more to fully disprove the phlogiston theory. And so for his third experiment, he focused on using oxygen to replace phlogiston. And so he conducted this experiment in June of 1783. And the way that he performed it was he took a flask and vacuum sealed it and removed all the air out of it to ensure that there were no incorrect readings. And so the top of the flask had a apparatus that allowed to have two hoses put in on the top. And so one of the hoses fed in oxygen and the other hose fed in inflammable air. If the inflammable part of air at the time was not known, and so he still needed to figure out the components of what it was to really finish his dis theory on phlogiston. And so the flask had an electric spark go through it, and that ignited combustion. And once combustion took place, water was formed at the bottom of the flask. And so this production of water was the last bit of evidence that Lavoisier did need to completely disprove the phlogiston theory all at once.
In experiment 1, air was collected as the phosphorus and sulfur burned. At the end of the experiment, there was an increase in volume. The increase led Lavoisier to believe air was involved in combustion. Although he wasn't exactly sure what the components of air were, he knew that air had to be involved because the weight of the substances before the experiment took place was much larger. In experiment 2, red mercury oxide was formed on the surface of a mercury sample. This formation led him to conclude that air was made of two components. One component was able to combine with the mercury and support respiration, and the other one was an asphyxiant. He knew that mercury consumed oxygen because the level of the mercury in the bell jar rose. Additionally, when the reaction took place, 16% of the gas was lost by the system. Then, when the mercury oxide was heated, it too lost 16% of its volume. This proved oxygen was part of air and part of combustion. During experiment 3, pure water was produced from the combustion of oxygen and inflammable air, which we now know as hydrogen. Then, the water was decomposed to get oxygen and hydrogen. He concluded that water was made of oxygen and hydrogen because there was an 85% and 15% composition of the elements. This further proved Lavoisier's theory that air consisted of two components. These results also proved that phlogiston wasn't an element involved in combustion, because when he decomposed the products of the combustion, which was water, it gave the same elements put into the reaction. The results from the 3 previous experiments led Lavoisier to create the law of conservation of mass and energy. The law states that energy and mass cannot be created nor destroyed, but they remain constant and can only be transferred from one form to another. In addition, he expanded upon Robert Boyle's nomenclature rules. With his new knowledge of reactions involving oxygen, the term mercury calx was changed to mercury oxide. He went on to write a textbook called Elements of Chemistry. He outlined the new nomenclature rules and different properties of chemical reactions.